All right, so we are in 6-1 today talking about repeating decimals, and here's our learning target. I can perform division between two integers and continue this process until I get a remainder of 0, or if we see that there is a pattern of remainders that happens, that tells me that what we have is a repeating decimal, and then we can notate that in the repeating decimal form. Question?
Also, isn't it for repeating decimals? You don't have to do that dot method. Can't you just do the bar?
You can. You can either use the dot, 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 which is actually, anyone know what the technical name for the 3 dots is? It is called an ellipse. Or you can use the repeating bar, which you put the bar over, exactly what repeats. So there's a few different ways that we can determine repeating decimals. One is just seeing a pattern in the remainders. I get a remainder of 2, I get a remainder of 2, I get a remainder of 2, the same remainder happening over and over again. Or if I see a pattern, not just the same one number, but the same set of numbers. So maybe I got a remainder of 1 and then a remainder of 2, and then a remainder of 1 and then a remainder of 2. And when the same pattern starts to happen, that would also tell me that this value repeats. The biggest thing about the dot, dot, dot versus the repeating bar, whatever's under the bar repeats that pattern. The dot, dot, dot isn't very specific about what is repeating. So I encourage you to use the bar. But we have a rule for converting a fraction with a denominator of 9. And sometimes we use rules to make our life easier. And not that I just want you guys memorizing things, but mathematicians create rules or theorems to just more quickly solve problems. Anytime we divide by 9, we can use this specific rule. So if I look at, let's say 4 9ths. Sure.
Okay.
Numerator goes inside. If you have a hard time setting up the division, numerator goes inside. Does 9 go into 4? Nope. Set up the decimal. Does 9 go into 40? Yes. How many times does 9 go into 40? 4 times, right? What's 9 times 4? 36. I get a remainder of 4. Drop down my 0. How many times does 9 go into 40? Oh, look, 4 times. I get the same remainder over and over again. If I kept doing this, it would keep happening. So this repeated remainder tells me that I'm going to repeat. Now, be careful though. This remainder is not why I have 4s up here. That remainder is not why I have 4s up here. But because my 4s start repeating, we see that this is in fact a repeating process. It's going to repeat that value that I've been getting. Izzy? How many times 9 goes into 1.6? This is no longer 4. We ignore the decimal when we're doing the long division. Because remember, place value doesn't matter when I'm doing these subtractions. These are not hundredths places or thousandths places. They don't have place value when I'm doing the long division. So yeah, just remember, this 4 minus, this is actually 40. Because I'm using 2 numbers, I have to subtract 2 numbers. So wait, so 4 9ths gave me 0.444444. What about 8 9ths? And if you're running out of space, you don't necessarily have to write this, or you could grab a Post-it. Does 9 go into 8? No. Does 9 go into 80? Yes. 8 times gives me 72. I get a remainder of 8. I drop down my 80. Again, I could fit in 8 more times. 72, drop down a 0. And I have the same thing happening over and over again. Sorry, that 8 kind of looks goofy. So can anyone see a rule or a pattern? 4 9ths was 0.4 forever. 2 9ths is 0.2 forever. 8 9ths is 0.8 forever. Xavier?
Whenever you have 9 as the denominator, the numerator will always be the decimal.
Yeah. So you could just say your rule is repeat the numerator. When you have division by 9, all you have to do is repeat the numerator as long as it's a proper fraction. So this does not work with improper fractions. It has to be a proper fraction first. So let's look at some division by 11. And actually, I might make a rule that relates both of these together. 2 11ths, because this would actually be the fraction 2 11ths, in case you need help seeing that, is 0.1818. So I see I have an 18 repeating. Let's look at 3 11ths. I'm just choosing it. It doesn't, like, we could do 4 or 5 or 6, whatever. I'm just setting up a division so we can look at it and try to figure out these rules. I really am pushing this year for you guys to, like, have these discovery moments as opposed to me just spoon feeding it. So instead of, like, when your parents, when you're a baby, you can't even eat for yourself, they spoon feed you. We want you now discovering you're not a baby anymore. You've got this sort of stuff figured out. Hopefully you know how to do this long division, but if you don't, let's discuss the process. Can 11 go into 3? No. Can 11 go into 30? Yes. 2 times. And that 2 times 11 would be 22. And I get a remainder of 8. I drop down a 0. Since 11 can't go into 8, it goes into 80. Can 11 go into 80? Yeah. 7 times would give me 77.
I love that.
Now I get a 3, so I drop down my 0, and I get 30. Can 11 go into 30? Yup, 2 times. Gives me 22.
Okay, I'm running.
I get 8. I drop down my 0. I get another 7. And I see that I have a pattern of remainders. I had a remainder of 8, then a remainder of 3, then a remainder of 8, and I'll get another 3 when I subtract my 77.
We do that like line? Like, not line.
The arrows dropping on the zeros if you need to remember that. But you're talking about the repeating bar.
Okay.
So we see that the 2 and the 7 repeat. So put a bar over the 2 and the 7. So if I relate 2 11ths gave me 18 repeating. 3 11ths gave me 27 repeating. I'm going to see if anybody can figure this out. 4 11ths would be 45 repeating. 36 repeating. 5 11ths would be 45 repeating. What is it, Izzy? Factors of 9. 6 11ths would actually be 54 repeating. So here is how you do it. You take the numerator and multiply by 9. So our rule here is just numerator times 9 repeats. So division by 11, you just multiply by 9. And here's the part where I might blow your mind. So really, we could say multiply by 9. So divide by 11, multiply by 9. But also, when we said the numerator repeats on the division by 9, if I divide by 9, up here, if I divide by 9, just multiply your numerator by 11. 2 times 11 is 22. 22 is what repeats. 4/9 gave me a repeating 4, or 44. 8/9 repeats 88. So if I divide by 9, I can multiply the numerator by 11, or if I divide by 11, I multiply the numerator by 9. These flip-flop, and the rule works either way. What'd you hear?
What I said.
No, it's not. Don't think of it as reciprocal. The rule just works either way around. So, these repeating decimals, I see that since 2 repeats, I know this would be 2/9. Since 18 repeats, that's a multiple of 9. That's 2/11, because 2 times 9 would give me the 0.18 repeating. 54, this is going to be 3 and, well, 54, is it a multiple of 9? Yes. So it's the 6th multiple of 9, but that's 6 over 11. Because it's 3 and the repeating decimal. It's 3 and the fraction. And then these are obviously not repeating because they don't have the bar and they don't have the ... So if we were to look at these 3, if I look at number 1, Atticus, if I look at number 1, what repeats there? What numbers actually repeat? Yeah, the 85. The 9 is not under the bar. It does not repeat. So this would actually be 3.9858585, and the 85 is what repeats. If you want to write a couple sets so that you know. Does number 2 repeat, Lily? 40400. It looks like there might be some kind of pattern starting, but it's not repeating. Nothing has actually repeated itself because it's been changing. Now in 3. Colin, in number 3. Am I missing? He's gone now. Of course. Jahim, in number 3. What repeats? Is it clear whether it repeats the 2 or the 7 and the 2? I feel bad because this is kind of a trick question. We're not 100% certain here. Hayden, what are you thinking? Well, it does repeat. So yes, this is repeating. This one's not. But we don't specifically know what repeats. So we would have to make an assumption. Hayden? So the problem is, this could be 727272, or this could be 22222, and the 7 could only happen once. We're not certain. This is why the bar is better. And that bar is technically called the repetend. The repetend, or the bar, is the better option. Any questions? It's just more clear. Now, if you were going to use the ... I just encourage you to show the pattern before you use it. So, if I was going to use the ... I'd want to say like 2727 ... Show the pattern that repeats. I'm repeating 27 instead of just saying 27 ... This is kind of rude. Leaves people curious. So, remember our rules. The 9ths, we just multiply by 11. The 11ths, we multiply by 9. Try to fill in this table. try to fill in your table. If you use your notes, you should get 100% on the homework. First time. If you use your notes and you work carefully, you should get 100% on your homework the first time. Somebody in the accelerated class literally came to me and they're like, Mr. Hudson, your homework kind of stunk. And I was like, what do you mean? They're like, you used questions that were on our notes. I said, yeah, that was on purpose. They said, well, it was really easy. I said, yeah, that was on purpose. I said, okay, well, I got it done. I said, great, that was on purpose. I wanted you to get it done. So 1/9, Bella, what would 1/9 be? Ooh, not, because we changed it out of fraction form. It's decimal 11. Yeah, but that repeats, so it just repeats 1. 2/9, Izzy? Yeah, it just repeats the 2. And if I'm only repeating one number, the bar could be over 1 of that number, 2 of that number, 10 of that number. It doesn't matter how many I show. Grace, what about 3/9? 0.3 repeating. 4/9, Xavier?
0.44.
Yeah. 4/10 repeating or 0.4 repeating. And Michaela, what about 5/9? So 1/9 repeated the 1s, 2 repeated the 2s, 3 repeated the 3s. Yeah, 5/9 will repeat the 5. Now, this batch, you guys get a little bit harder problems. Kylie, what about 1/11? Now this is really tricky because the rule we wrote down is you just multiply by 9. But if I multiply my 1 by 9, that's going to be 0.9 repeating. This is the one tricky one. This is 0/1. Because the denominator is a 2-digit number, we need to be thinking of it like 2-digit numbers. This is 0/9 repeating. So, because 1 times 9 is just 9, but it's not 9/10, it becomes 9/100 repeating. Now it gets easier after that. So Kylie, you want to try 2/11? Yeah, the 18 repeats. CJ, what about 3/11? Yeah, 0.27 repeating. 4/11, Justin? Yeah, 36 repeating. And 5/11, class, give it to me. 45 repeating. Any questions on any of the 9ths or 11ths? So that's the main part of your homework, is being able to divide by the 9s or being able to divide by the 11. 7/15, there's not some special trick. So if we're asked to write as a decimal, set up the division. 7/15. No. Yeah, you can probably start with 3, but I like to put a lot in case I need them. Then they're there already. I cannot fit 15 into 7, but I can fit 15 into 70. How many times?
Isn't it like 4?
Ooh, bigger than that. Colin?
Wait.
6.
I
Because
didn't say that.
sorry, I'm ahead of myself. It is 4. 30, 60.
You.
There's one where we use 90. Sorry, I was thinking 90 instead of 70. Look, we all make mistakes. 100. Now it fits in 6 times. I get 100. That fits in 6 times. I get 100. Yeah, because this 100 is spitting out 6s, and the 100 starts to repeat, I know that these 6s are going to repeat. But again, the ... is not very friendly here because this really becomes 0.4 with the 6 repeating. So you could just put a bar over just the 6. Even though it starts with a 4, it then turns into a repeating. Now here's the question that a lot of people like to answer before they think. Are repeating decimals, like what we just got, 0.4666 forever, are repeating decimals rational values? Are repeating decimals rational values? Izzy? Pi is not repeating. Pi is endless, but it's not repeating. You think what? It is or is not rational? Is. What makes a rational number? What's the definition of a rational number? Abby? Number that can be written as a fraction or ratio, right?
But it's a terminating.
Says who?
The definition.
That wasn't in the definition. Definition of a rational number is any number that can be written as a ratio. Is this number able to be written as a ratio? Yeah, it's 7 to 15. It is 7/15. It is in rational form when we start. This is a rational number because any number that can be written as a fraction, hey look, it's written as a fraction, is a rational number. So do not fall into the trap. People say, oh, it repeats. That can't be rational. Yeah, it is. Every repeating decimal is a rational number because it can be written as a fraction. Justin? Yeah, it can. Not as a decimal, but it can be written as a fraction. So take one of our very favorite repeating decimals.
I love that noise.
0.3 is forever, right? How do I write that as a fraction? Xavier? It's not 3/10 because 3/10 would stop right here. Andrew? What? 1/3. This is much nicer in fraction form. I can put it in a decimal form, but it's not very nice. What if instead of 1/3, I have 2/3? Really, this is 6/9. Because if I multiply by 3 and I multiply by 3, these are equivalent to each other. 0.6 forever. But it is a rational number because it can be written as a ratio. I have 2 minutes and well, maybe I do. No, I don't. I forgot about the new schedule this year. We're out of time. So that is everything I have. 34 instead of 36. It used to be 36 last year. Now it's 34. So get out of here, guys. We will pick this up looking at the sevenths, and I will probably blow some of your minds when we deal with the sevenths.
Are you ready? Did you say that you're saving the world because of the Nalgene bottles? Because they're like
You are
friendly or
one
something?
bottle at a time. No, because you're not using